welcome to section 1.1 of Business Math, Linear Equations and Inequalities. Hope you've been taking good notes. We will begin. I am going to cover what I feel might be the more challenging equations here. So as you know, to solve a linear equation, we perform these operations on the equation to obtain simpler equivalent forms until we attain an obvious solution. So let's look at something like this if we're trying to solve. If I have fractions on both sides, the easiest way to solve this is to find something that both of these can multiply into. So in other words, I will take this side. I could make it 8, so 4 times 2 is 8, but I see they're both divisible by 4, so I can multiply both sides by 4. This side, the 4's are going to cancel, and I'm left with x plus 1. This side, since there is a plus in the middle, I need to distribute that through. 4 over 2 is 2, so I'm going to be left with 2x on the numerator here, plus 20. And as we know, I want my x's to be positive, x from both sides, and I'm going to subtract 20 from both sides. That cancels my x's on this side, and it cancels my 20s from this side. So here I'm left with x equals negative 19. Okay, let's move it on. Next, solving for just a variable. Well, here I want to solve for n in this equation. Well, I see my equal sign here. On this side, I see two n's. If we ever have two of the same variable, we want to get them on the same side of the equal sign, which this is the case, and I want to factor it out so it turns into 1. When I factor out that n, I have 2 plus t plus r left equals m. Beautiful. Now my n's turned into 1n, and to get it by itself, I'm going to multiply by t plus r over t plus r. Cancels out, and I have my solution. N equals m over t plus r. Great. Now let's jump into linear inequalities. Okay, as you know, an inequality is one side is greater or less than the other side. Here we can just mark, obviously, 4 is less than 12. So the bigger side will open to the larger number. Negative 10 is less than negative 3, because we get on the negative side of things and they become less than as the negatives get larger. Okay, what about here? Negative 19 is less than 0. So let's look at inequality properties. Okay, so when we look at interval notation, interval notation and our inequalities on how to graph these and everything else. Okay, multiplication by 0 and division by 0 are not allowed. So let's just go over that as we go to both sides of it. Inequality. So when we're looking at our interval notation, okay, our brackets mean equal to. So here's our inequality notation. We could have our x in the middle, and what this means on both sides is x is less than or equal to whatever that number might be, b, but it's also x is greater than or equal to whatever that number might be, a. On a graph, you'll see it graphed like this with the brackets because they are equal. A parentheses, it all goes all the way up and approaches that number but not equal to what it'd look like on the graph. Same here, parentheses on both sides. One thing we need to always remember is infinity will always get the parentheses because we are never equal to infinity. So here you see negative infinity, parentheses, up to a. So we can just put an arrow because it's going to go on forever. And we can put a is greater than x. Okay. Here you can say x is less than a. Well, I'm sorry, that was equal to because we have the bracket. Apologize. X is less than a because we have the parentheses. And then, of course, our opposite way when it's greater than. Okay. So let's just look at a first degree linear equality where we're just dealing with lines. Here, we just want to get the x by itself. So we're just going to treat the inequality like a equal sign, except when we're multiplying or dividing by a negative number. So we'll work our way through this. 3x minus 3 less than 5x plus 10 minus 5. Combine our like terms. We have plus 5 over here, 5x plus 5, and 3x minus 3. We are still less than. I am going to get my x's over here because I like keeping my x's positive, and 3's are less than 5. So if I subtract 3x from both sides, then I'm left with 2x here. Then I get this 5 over here. I'm going to subtract 5 from both sides, and I'm left with negative 8. So I keep my inequality the same. Okay. Now, if I were to go the other way, then I would subtract 5x. I would end up with a negative 2x, and then I would have to divide by a negative 2, and it would switch my inequality anyway. So now I'm just going to divide by a positive 2, so I don't need to switch my inequality, and x is greater than negative 4. We were to put that in interval notation, then I could put, since it's a not equal, then I could put negative 4 to infinity. If I were to put that in an inequality, well, I've already got the inequality. If I were to graph it, I would put parentheses and an arrow, and this would be negative 4. Okay. Let's see if we can get on to some more challenging, and then we will wrap this one up. Here is going to be the same as I pointed out. What would we multiply both sides by? Can't multiply by 5 because 5 is not divisible by 2. But if I multiply these together, 10, I could multiply both sides by 10 and simplify that, get rid of my fractions, work from there. Here, now we have two inequalities. What happens when we have two inequalities and our variable is in the middle? Well, I'm just going to do the operation on each side. So if you like, you can put your lines here. But if I want to subtract 32, then I need to subtract 32 here and subtract 32 here. Okay, gets rid of it in here. I have 9 over 5c, greater, less than or equal to, and greater than or equal to. Here I have negative 36, and here I have, what is that, 36. Okay. Multiply by 5 and divide by 9, or I could multiply by 9, apologize there, 5 over 9. Multiply by 5, divide by 9. Multiply by 5, divide by 9. Gets rid of that on there, and then I would have C. And if I put that in my calculator, I have 36 times 5 divided by 9 gives me 20. So on this then, I would have C is less than or equal to 20, or greater than or equal to negative 20. All right. I think we're about to wrap this lesson up. Let's do a little bit of what we might see as a word problem. You'll have several in this lesson, but let's look at what we might have here. Companies use, get rid of that here, what's going on? Okay. Profit loss analysis. Companies use profit and loss analysis to support decisions regarding the pricing of products and appropriate levels of production in order to maximize company profit. A manufacturing company has costs C, which include fixed costs, okay, like plant overhead, product design, setup, and promotion, and variable costs. Costs that depend on the number of items produced. The revenue, or which is the income for a company, is the amount of money that the company receives from selling its products. The revenue is less than the cost, the company loses money. The revenue is equal to the cost, the company breaks even. The revenue is greater than the cost, and the money makes a profit, which is what profit is. Profit is equal to the revenue minus the cost. So when the profit is less than zero, then you have the company loses money, as we just wrote it here, okay? Equal, the company breaks even, and when it's greater than, the company makes a profit. So often it is helpful to find when the company breaks even, and this is called the break-even analysis. So let's look at a procedure for solving word problems. Read the problem carefully and introduce a variable to represent an unknown quantity. So we're going to introduce a variable to represent an unknown quantity. Okay. Often the question in the problem will indicate the appropriate choice for the variable. Number two, we're going to identify other quantities in the problem, known or unknown, and express unknown quantities in terms of the variable you introduced in step one. Number three, we're going to write the verbal statement using the conditions stated in the problem, and then write an equivalent mathematical statement, an equation or an inequality. Then we're going to solve the equation or inequality and answer the question posed in the problem. And then we'll check the solutions in the original problem. So we'll do one example here real quick. Let's see. University Club plans to raise money by selling custom printed t-shirts. They find that the printer charges $400 for creating the artwork and $3.50 per shirt that is printed. If they sell the shirts for $15 each, how many shirts must they make to break even? Okay, so we want to look at what the break even point is. So if they charge $400 plus $3.50 for each shirt, and if they sell the shirts for $15 each, then how many more shirts must they sell? So we're going to put equals 15 times X. This will be the break-even point because this is what they're selling them for. So this is our revenue, and this is our costs, 400 plus $3.50 per shirt. So we're just going to solve for X. Let me subtract 3.5X on this side, subtract 3.5X on this side, gone, and we have, what is that, 11.5X equals 400. Divide by 11.5X, or 11.5, I'm sorry, 11.5. And what do we get here? 400 divided by 11.5 gives us 34.78. So really we're going to make it 34.79 because there is a little bit of 34.782. 34.79. So that's what they would need to break even, or that's what how many shirts they must sell. So since we have to make this a whole number because we can't have that part of a shirt, then we will say they need to sell 35 shirts. And let's just write down 35 shirts. Okay, moving this around here. Okay, you'll have several other word problems to work out in this lesson. Take advantage of the steps I've shown you earlier to solve your word problems, because we're going to have plenty in this course as we move along. Here are your steps. Has that moved away here? Okay, write these down and make sure I'm worked through them. See you in the next lesson.